Hi everybody, I hope that all of you are doing well. Welcome to lab 212 and lab 252, and this is our second lab, and hopefully it will be interesting and enjoyable, guys. So what we will study today, we will study the resistance, and we will try to measure some resistance, and also we will try to apply Ohm's law to know the resistance. So let's get started and introduce the material that we will need for today's lab. So what we will need this power supply. So this power supply is around 12 volt DC, and we will need this motor. This is like small electric motor. We will need it just to make sure that there is electricity in the circuit. We will need some bulbs here, as you can see, bulbs. These are the regular bulbs that you have in your house. Also, we will have some pencils, sharpened from both sides, as you can see here. So what we will have group of these pencils, as you can see here. Also, we will need a multimeter. So the multimeter will help us to measure the current and also measure the resistance. So just to give you a kind of brief introduction about the multimeter. So these are the connections that we use for the multimeter. Keep them here, and actually this is the multimeter. So you can see, guys, here there are like several ranges here. So you can see this range can be used to measure the ampere just with the alternating current, as you see here. So we have like wave sign here. This side can be used to measure the current. This is for the DC. Here, this range can be used to measure the resistance in ohm. And there are other, so this is for the diodes, and this is for the volt, DC volt, and this is for the AC volt. And this side, guys, is just to make sure that there is a connection in your circuit or not. So that will give you a sound. So this is the multimeter. So what we will use here, we will use this side, which will help us to measure the resistance. And then we will use this side, which will help us to measure the ampere. So this is everything. The other thing that I would like to share with you, so if you would like to measure the volt and resistance, so you need to have those connections fixed here in this side. So now you can measure the resistance, as you can see, and volt. What if you decided to measure the ampere? To measure the ampere, look at here. So here you have microampere, milliampere. So just you need to fix this here. So now the multimeter is ready to measure the ampere. And to measure max 10 amperes, you need to fix that here. So this is everything I believe about the multimeter. It is simple, and we will get started and start today's lab. So now you know the material that we will use. So we introduced everything. We introduced everything here. We introduced the multimeter, the pencils, the bulbs. So let's keep the bulb here. The bulbs, the small electric motor, and the 12 volt power supply here. Okay, guys, let's now start the lab and have some measurements. So the first step in today's lab is to measure the resistance, and just have something physical in front of us so we know how to measure the resistance. So here, guys, what do we have? We have a pencil, so you know the pencil, and the pencil just was sharpened from those sides, as you can see here. But what do we have here inside this pencil? Actually, we have the graphite, and the graphite is considered as a material that that has kind of resistance. So we can use it to create resistance and measure the resistance. So here I have like several pencils here with several lengths, and we will test all of them. And what I would like you guys, I would like you to just write what you have seen in this lab. For example, in the worksheet, if I asked you about the resistance for the pencils, just respond with your understanding. Yeah, so what I will do here, I will show you everything, and then you will go to the worksheet to answer the questions that are related to this part. Also here, what do we have, guys? We have bulbs. So we know that the bulb has resistance inside, and this resistance can help to create the light, because the current goes through the resistance, and then the resistance gets hot, and then you can see the light. So these are kind of traditional bulbs that have resistance inside. So what we will do, guys, we will just measure the resistance for these bulbs. Yeah, so here it is clear. I believe you can see the wire inside. Yeah, maybe if I did something like this, so that can help you to see the wire inside. Maybe that can help. Yeah, so this is the wire that has the resistance. Yeah, so now let's get started, guys, and measure the resistance and write it down here. So let's do that. So we have here a piece of paper to write our data, and here we have the multimeter. So let's start the multimeter and see. So firstly, we need to choose this range. So this range, as you can see, is 100 ohms. So this is the max. This is the max for the pencil, so it's a good idea to have this range, guys. Now I will start with the first pencil and see what do we have. So I will have the multimeter here in front of you, so you can see those numbers. So let's get started like this and measure the resistance and see what do we have here, guys. It's going down. Let's wait until the number became stable. Yeah, so it is around 21 ohms. So this is our number one. It is around 21 ohms. So this is our number one. Let's now try with another pencil, which is this pencil, and see the resistance here. So I will try to measure it. Yeah, you can see it is around 12.5 ohms. 12.5 ohms. Yep, let's adjust the camera so you can see better. So this is our number 2. It is 12.5 ohms. Let's now move to another resistance, which is this pencil, and see what do we have for this pencil. So the resistance, is around, I will keep it here so you can see it. Wait until the number became stable. So let's see here. Yeah, so here we have 22, around 22 ohms. So this is our number 3, which is this pencil. Now I will move to the next pencil, which is this one. I believe this pencil was broken from inside. I don't know if there's connection through this graphite here, but I will try to measure it, and hopefully we can have a number here. I will try to measure it. Let's see here. See. Oh, it works. Great. Yeah, so you can see it is around 11.4. So here we have 11.4 ohms. So this was for this resistance, for this pencil. So let's now try another one. What about this short pencil? Let's see. Try to measure the resistance here and see how much resistance do we have here. Yeah, so approximately we have like 17.5. So R4 is equal to 17.5 ohms. Great. Now I will move to the next pencil, which is this pencil, and let's see its resistance in ohms, of course. Yeah, so let's see here, what do we have? It wasn't sharpened very well, but I would do my best to keep it connected here. Great. So we have some numbers here, and you can see that this number is in ohms. So 16.7, 16.4, yeah, so it is around 16.5 ohms. So this is our 5. There is another way to measure the resistance, which is when you measure the resistance, for example, for this pencil, you can have more than one reading. So you can see that the reading is not stable. It goes up and go down, goes up and go down. So what you can do, guys, here, you can have all of these readings and write them down and then sum them up and have the average, and then also you can calculate the standard deviation, so you can have the error with the number. So yeah, and the number would be, for example, the resistance is equal to, for example, like 25 plus minus like 5 ohms, 23 plus minus 2 ohms, and etc. But what I did here, I just got the most stable number. We know that those numbers like goes up and goes down, go up and go down, as you can see here. So you can see those numbers, so go up and go down. Yeah, so here you can see this number go up and then go down. Since the number is going down, continue to wait until you see that this number is stable. Oh, so right now we got, yeah, so we got 16, like 16.5. So this is one way, but it is fine to just measure the resistance just for once and try to to hunt the stable number. Okay, so this is the last pencil. Now let's check those bulbs, guys, and see what's the resistance for these. So I will start with the first one, and then what I will do here, I will give this bulb, I will write number 1. So this is bulb number 1, and I will have number 1 here, and see what do we have. So what I will do, I will fix one of the terminals here and the other one right here, and see the resistance. Yeah, so you can see the resistance for this bulb is 37.5 ohms, and it is stable. Let's measure it again. I just was wondering what's the number after the point. So it is 37.6. Yeah. Okay, so this is bulb number 1, and we got 37.6 ohms. Let's check now. So this is bulb number 1. Let's check now bulb number 2 and give it a number as well. So this is bulb number 2. So it's number 2, as you can see. And let's measure the resistance and see what do we have here. Okay, so we have 46. Okay, 46. So we have 46 ohms for this bulb. So here we have 46 ohms. So this is bulb number 2. Let's now check bulb number 3. I'll write down here 3. So this is bulb number 3. Let's see what do we have here. Just try to connect those terminals and see what do we have. So here we have 44 ohms. Great. So we have 44 ohms. For this bulb, which is bulb number 3, we have 44 ohms. So here we have 44 ohms. Also, I was looking for something that can be resistance and give us kind of high resistance. So what I found this bulb. It is different bulb. It has kind of different resistance inside, maybe ceramic resistance here. So let's see the resistance for this bulb, which is bulb number 4. So this is bulb number 4. So let's see the resistance here. The resistance can be measured like this. Connect those terminals, one of them here and the other one here, and see what do we have. So with 200 ohms we have nothing. Let's change the range to 2000. We have nothing. 20,000. We have nothing. 200,000. Let's see, the range is 200,000 and we still have nothing. What about 2 million here? Also with 2 million or 2 mega we have nothing. When we turn it to 20 mega, okay, oh, look at. So it is around, we will wait until this number fixed, so it is around 11 point, so 27, 26, okay, 12, oops, let's have it fixed here. Wait, so 11.19 mega ohms. So this has like very big. So 11.19. So we have 11.19 mega ohms. So this is like very big resistance that we have among all of these examples. Yep, so this is step number 1. So you know, guys, that the resistance can be measured as I showed you. So this is step number 1 of today's lab. Let's now go to step number 2. Hi everybody, this is step number 2 from today's experiment. So what do we have here in front of us? We have the multimeter that we will use to measure the resistance, the equivalent resistance, and we have those bulbs. So these bulbs will be considered as resistors, as I mentioned. Right now they are connected in series. So they are connected in series. What do I mean by connected in series? So they are like this. They are connected in series. So we can see here that we have R1, R2, R3 connected in one line, as you can see here. So what we are going to do, guys, we are going to measure the equivalent resistance and make sure that the equivalent resistance is equal to, here you can see 127.6 ohms. So this is the equation that used to calculate the equivalent resistance for resistors that are connected in series. So we should have 127.6 ohms. So as we measured earlier, we measured that R1 is equal to 37.6, R2 is 46, R3 is 44 ohms. Let's now double check and see experimentally if we can get this number. So what we need to do, guys, we need to start the avometer or voltmeter, for example. So we start it, and then we need to go to the resistance range here, which is an ohm, and just we need to keep it on 200 because the equivalent resistance shouldn't exceed more than 200. So now what I'm going to do, I will keep this in front of you guys, and also what I will do, I will focus like this, so you can see here everything. So you can see the resistors, and at the same time you can see the ohmmeter. Yeah, so I will go a little bit back, so I believe that's perfect. Now what I'm going to do, guys, I will test these resistors. So let's do that together. So I need to come here and fix one of the terminals here on this side, as you can see, and the other side should be here. So let's see, what do we have? We have 125, 126, 126, 25, 26. Yeah, so what you can see here, guys, you can see 126.5, let's say 0.5, which is approximately 127. So this is the second part, guys, and we need to write this here. We need to write this here. So experimentally, we got 126.5 ohms. So this is what we got when we connected these resistors in series. Now we will go to the next step, which is connecting these resistors in parallel and see what we will get. This is part 3 of today's experiment, and here what we can see the same bulbs, the same resistors here, So resistor number 1, resistor number 2, and resistance number 3. And they are connected in parallel. So what do I mean by connected in parallel? So we can see here that these resistors are connected in parallel. So we have R1, R2, R3 are connected in parallel with the other resistors. So and now what we are going to do, we are going to measure the equivalent resistance for these three resistors. So but before we do that, we need to go through the equation that we use to measure the equivalent resistance in parallel. So 1 over R equivalent is equal to 1 over R1 plus 1 over R2 plus 1 over R3. So by doing some math here, there is some math work here, guys. After we do all of this math work, so we will explain that. If you have any question about this math work, just send me email, guys, and I will explain it to you. But what I did, I just gathered everything and made it just one term here. And then the next step is to have the final form here. This is the final form for the equivalent resistance for all of these three resistors. So we can see here, after we calculate from the measurements that we made, so we know that R1 is 37.6 ohms, and resistance 2 is 46 ohms, and resistance 3 is 44 ohms. And what we did, we substituted them here with these R's, so we got this result. So the equivalent resistance for these bulbs that are connected in parallel is 14.07 ohms. So let's measure it together, guys. So right now they are connected in parallel. So what I will do here, I will bring the ohmmeter here in front of you and try to adjust and zoom a little bit like this so you can see everything, guys. Now let's see the equivalent resistance here by measuring the equivalent resistance for these bulbs experimentally. So let's see, what do we have here, guys. So as you can see here, oops. Okay, let's do that slowly. So we can see 14.6. I'm sorry, 14. I have to keep this fixed here. So we have 14, 16, 15. Maybe because I'm moving these bulbs, but I will try to hold them and measure it again and see what do we have here. So 14, oops. So we have 14.1. So it is 14.1. I will do it again just to double check with you guys. So 14.0. Great. So it is 14.0 as you can see, and it is stable number. So we will use this number, guys, 14.0 ohms. And if we go here to the number that we calculated, we will notice that we have 14.07 ohms, which is correct, and the error is very small, I believe. This is great, guys. So we are done with the step number 3. Let's go now to step number 4, which is related to Ohm's law. This is the last part of today's experiment. And in this experiment, we will try to find the current. So how can we do that? We can find the current by using this circuit that you can see here. So what we have here, we have the power supply, which is 12 volt DC, 12 volt DC. Here we have electric motor. So this electric motor will tell us that there is electricity goes in this circuit. This is the job of the electric motor here, because I don't have bulb. So that's why I use this electric motor. Here we have two resistors. Resistance number 2, which is 46 ohms, we measured that, and the other one is 44 ohms, and we measured this as well in part number 1. So the equivalent resistance is 46 plus 44 ohms, and is equal to 90 ohms. So this is the circuit that we are working on right now, and we will use the multimeter here, or the voltmeter, to figure out the voltage between those two resistors. So what I will do, I will measure the voltage between those 2 points. So let's get started. So we have the avometer here, or the voltmeter. We have the electric motor here. We have the power supply right there, and we have those 2 bulbs, which work as resistors. So let's get started, guys. So there is electricity right now. There is DC volt right now. It is working. So what I will do right now, I will show you how to make sure that there is electricity. So you can see that this electric motor will work. So it's working, as you can see here. And what I will do right now, guys, I will measure the voltage between the ends of these 2 resistors, and we will apply Ohm's law. But let's get started, guys, and measure the voltage here. So let's see. So we need to fix one of these terminals here, and the other one should be here. So what we have, as you can see in the voltmeter, we have 18 volt. So what we have 18 volt. So it is 0. We have 18 volt, 0, and we have 18 volt. So now we have 18 volt. What we need to do right now, guys, go back to this circuit and review everything here. So we mentioned that there is a power supply here, the electric motor here that tells us about the current, flowing the current. Also we have 2 resistors here. Since we got the volt between those 2 points is 18 volt, and the total resistance here is 90 ohms, so it is easy now to find the current. And to find the current, guys, what you need to do is to apply Ohm's law. So this is Ohm's law, as you can see here. So Ohm's law tells us that voltage is equal to current times resistance. The unit of voltage is volt, the unit of the current is ampere, the unit of the resistance is ohm. So now the current, by dividing both sides by R, so we can get the current is equal to V over R. And then we need to substitute V with 18 volt that we got from the experiment, divided by 90 ohms that we got also from measuring the bulbs, those two bulbs which represent the resistors. So by dividing them, as you can see here, we will get 0.2 amperes. So this is, guys, the current. So this is the current that flows in this circuit. So now you can see how Ohm's law is important. It helped us to find the current that flow in this circuit. So what we can do now, so we can say that this circuit has 0.2 ampere current flow in it. So this is great, guys, and this is the end of our today's experiment. Hopefully you benefit from today's experiment. So what I would like you to do, guys, I would like to write report, just report summarizing what we did in this experiment. So you saw the video and you saw all of the parts of the video. You saw how to measure the resistors, how to do the other parts. So just write report, guys, and this report just summarizing what we did in this experiment. So this would be your worksheet for today's experiment. Thank you so much, guys, and see you next week with another experiment.